Right. Hello, everyone. It is 11:30 Central, so we will get started. Thank you for tuning in to today's presentation, Shockingly Effective Teaching Electricity for Real-World Learning. My name is Kelsey, and I will be your moderator for today's presentation. First, here is your 30-second introduction to Realityworks for those of you who aren't familiar with us. We are an employee-owned company based in Eau Claire, Wisconsin, that creates experiential learning tools for teaching job and life skills. We got our start over 20 years ago when former NASA engineer Rick Germain created the first RealCare baby infant simulator, and then went on to found the company that is now Realityworks. Today, our training tools combine curriculum with hands-on learning tools, student activities, and assessments. Baby is still around, but now you can look to us for our tools like our bovine birthing and ultrasound simulator, our virtual welding simulator, our wearable geriatric sensitivity suits. If you have some time, we encourage you to check out our website and see it all. Presenting today, we have Todd Hunter, who is the STEM and Career Exploration Product Manager here at Realityworks. Todd is an experienced educator in leading innovative curriculum design, and he has over 19 years of experience as a STEAM teacher and program developer in Minnesota. Before we get started, I want to cover a couple things. First, today's presentation is being recorded, and all attendees will receive a link containing the recording, as well as a copy of the PowerPoint slides and free resources. For those of you attending live today, you will also receive a certificate of completion for attending today's presentation. Keep an eye on your email. You will receive that email within 24 hours after the presentation. We will have time at the end for Q&A, so feel free to type your questions in the chat or Q&A feature located at the bottom of your screen. With that being said, I'm going to go ahead and pass things over to Todd.
Awesome. Thanks, Kelsey. So like Kelsey said, my name is Todd Hunter. I was a public high school teacher for 19 years before joining Realityworks, and today I'm responsible for directing the development of our STEM and trades career exploration products, which is pretty awesome. One of the things that I very much enjoy about being here at Realityworks is we really do put teachers first when we think about what we're building and what we're developing. And so today, as we jump through pretty rapid fire, I'm going to move real quick. I'm going to put my teacher hat on and rely on my time in the classroom working with students to really guide our discussion. All right, I got to switch the slide. There we go. Our goal today is to work through these things. It's quite a bit to do, so I'm going to move fairly quickly. We decided to put this webinar together because when we listen to our teachers, one of the things that we hear most is electricity is really hard to teach. And over, we've heard that, and that has directed our efforts in developing new products, but it also means there's, a niche to fill to help teachers understand how to go about teaching electricity in a successful way. So I'm going to take you guys through some conceptual ways to think about teaching electricity. We'll take a look at two of our products that I think are just really, really effective. Then I wanted to show you E and F, some additional resources that are out there that I have found as a teacher, especially really, really effective. So let's jump into it. Why teach electrical concepts hands-on? Now, one of the biggest struggles with teaching electricity is that it is invisible. A lot of teachers where I was, me included, when it came to teaching electricity, I worked a lot in a engineering context, in a maker space, we would draw circuit diagrams, series and parallel and more complex circuits. After we introduced current, resistance, Ohm's law, and then we would build those things just using wire and simple parts and pieces. But where things fell apart is that students couldn't do anything with that knowledge afterwards, which if we switch lenses and talk about educational theory a little bit, transference didn't happen, right? So their ability to take what they learned about electricity and how to build circuits and then to apply those in different contexts was horrible. And I spent so much time going over and over and over those basics. Like, ah, gosh, guys, we already talked about this. We've done it. You're killing me here. Right. And so just to like play with that idea of transference a little bit, it's not just as simple as just, one kind. Is educational researchers sort of categorize transference in different categories or levels, and applying that to electrical understanding and application really helps us think about, okay, in the learning experience that I'm creating, how am I setting the stage for these different types of transfer? I would say the ultimate is that backward transfer, and in a project learning context, so one of my favorite activities we did is, this was with my younger freshman students, is LEDify a stuffed animal. So go into the basement, dig out that garbage bag of stuff that maybe is going to go to Goodwill. You have your old stuffed animals in there that you made your parents buy forever ago. We're going to gut it, and then we're going to build a circuit and make that thing a really creepy Halloween decoration. And how you do that is up to you, right? But the goal is I want you to take that learning and apply it to LEDify this stuffed animal. All right. And that was a great context for transferring that knowledge. I wish it worked as smoothly as it could have. There was always a challenge. Right. So, where to start? One of the things that we really strive to do in developing our products at Realityworks is think about that complete learning experience. And I find this really valuable as an educator as I think about what am I going to do in my classroom and how do I maximize that experience's effectiveness. Um, I work with Jillian Rohrig from the U of M Twin Cities. That's kind of where I'm at. Worked with her quite a bit on projects and different products. And she published this paper that we adapted into this STEM 7 pillars. And we kind of use this as a way to set the bar for us as we develop products to help teachers. We want to make sure that we're creating something for our teachers that can check off as many of these pillars as possible. I'm not going to dive into that. That's a different webinar, but if you're interested, just Google her name and you'll find her really amazing work. Now with electricity is one of those concepts that, I mean, you can get a whole 4-year and master's engineering degree in electrical engineering. But if we are teachers, right, how do we balance just the right amount of content and concepts, right, to maximize having a really effective and transference driving experience so our students actually learn what it is that we want. And that's kind of, this balance is what we're always juggling as teachers. And that's where these two products I want to talk about do a really great job of helping you balance. So the first one I want to look at is a really new one for us, is our trailer circuit STEM kit. And I feel really strongly that this complete learning experience does result in a really high transference, because you'll see, right, is we get students using the tools, we get them doing the work hands-on, and it's in a context, right, that connects to their real life. So it looks like, you can see in those pictures, a SUV or a truck and a trailer, and it mimics exactly the systems and the connections and the pieces and parts and tools that a student would see maybe their mom or their dad, all right, on their car working to hook up a trailer, which this is the time of the year where everybody's digging their trailers out, unless they are snowmobilers and such. So when you get this, you get 3 of these boxes. When you open up the lid, this is the decal that's in the top of that box. So students know exactly what all the pieces and parts are, and it kind of saves you the pressure of, Mr. Hunter, where's this? Or what's this? You just look at the decal. We try to set you up for success as the teacher, but then also, right, to make it really easy for your students to keep things organized, because that's a time suck. Now, this learning experience is really complete. And what we're hearing from the teachers who are purchasing this and they're already starting to use it, is that they're finding homes in tons of different classrooms for this, because it's really not just about automotive wiring. It is about establishing a foundation of electrical understanding in a really practical manner. So I worked with our subject matter expert, Jeff, who is an electrician, still is an electrician on the side, he tells me, to create a curriculum that meets the needs of, let's say, a science teacher who's teaching electricity from a more conceptual standpoint, but also the needs of an engineering or robotics teacher, or even a teacher who is more trained in CTE and looking at really practical applications, whether it's wiring a house or a commercial, whatever. These 8 lessons kind of go from 0 to 100. So we wrote it as a complete package so you as the teacher can pick and choose what works best for you. Do you need to go all the way to lesson 8? No, right? You can pick and choose what's best for your student. Now, one of the things that we heard from our teachers was that safety is such a big deal. And I would totally agree. I had so many students that got just scared off from electricity the first time they short-circuited something, and all of a sudden they've got a battery pack melting, or they blew up an LED, or a servo started to like twitch and fried itself. One of the really cool things about the trailer circuit STEM kit is our engineers designed this to act just like a 12-volt automotive system. So we'll dive into this later, but if you take a multimeter and you touch any of the 2 parts testing the voltage flow, you'll read 12 volts just like you would on a car. But we also made this what I call middle school boy proof, right? And you could literally lick both hands and just smash your hands and touch all of the terminals, all of the metal parts, and nothing will happen, right? So our engineers made this thing really smart. It pays attention to how things are being connected, and it controls the flow of electricity so that you can't create dangerous short circuits, you can't have accidental sparking, you can't even fry a light bulb. So this is a great way for students to sort of engage without being afraid because they accidentally screwed up. One of the things with electricity, right, because it is such a complex topic, is, and this is true with a lot of our products, is we want to remove the teacher from the front of the classroom, right? Instead of you having to be the one standing there guiding the learning experience, which means you're tied there, and if a student is struggling, it's hard to help them. We create these packages, these learning experiences that allow you to get away from the front of the classroom. So yes, you get 3 of the full packages, 3 of the simulators, but what I think is more valuable are the curricular resources that come with it. So like seriously, you could get this tomorrow, or let's say this package showed up today, you could load these student slideshows right into your Google Classroom or Schoology, right? The teacher's guide would kind of give you some background. It also has all the keys and everything you need. Also, you could upload the student workbook to your Google Classroom or LMS, and you could start teaching tomorrow. Everything's ready to go. The way I imagine it, or I would execute this in the classroom, is I would break my students up into groups of 2 to 4, give them each a simulator, right? They would pull up lesson 1, DC electricity basics, on their Chromebook or their device, and each student would have that student workbook, holding them accountable, and the workbook matches those LMS ready slideshows, and they just independently as a team are working, which lets you as the teacher bop around and troubleshoot and problem solve as needed. So we start, or I say we built this with the assumption that students don't know anything, right? And so all of the things you're going to see here today, you guys, are not things that I've created for today's webinar. These are just snapshots right out of the curricular materials that students have. And so we start really simple. This is just a quick like a combination, right? We start really simple with series circuits, and we guide students through every single step. We don't assume they even know how to measure 12 inches of wire. We also don't assume they know how to use the wire snips and strippers. So we take them through every single step, which, right, I have found really, really powerful for teachers also who maybe aren't feeling super confident with circuits or wiring or electricity in general, right? You don't have to be an expert to teach this because everything you need is here. Now, after a few times, you will be, right, kind of like an expert. So we start with series circuits, then we step it up to parallel. And again, right, we're guiding students through the whole process. I'm going really fast here because we're not trying to learn at the moment, but all of these come straight from the materials, those LMS ready slideshows that are set up for students. All right, and then, right, so we start really simple, and then we increase our level of complexity, and this is where we start building that context of real world application. We do that by working in, electrical information. We got to talk about, resistance, conductors, different vehicle wire types, right? And then we get students building hands-on. Right? And this is the same wiring harness that you would find on a car. So I could go out to my wife's vehicle, right, a little Toyota Camry, and I would see this dangling off the back because we installed a hitch. It's the exact same connection that I could go to Menards or Ace Hardware and buy. So what students are developing here, right, is a really easy to transfer set of skills and knowledge and an experience. They could go out and fix their trailer after this lesson, which is super cool. Now, this is where it gets even more impressive, and I'm so excited about this, right? Not only do we teach them how to wire, right, but we also teach them how to use the tools to measure. So the multimeter, the auto test light, once they've got it wired up with the four-way, we teach them how to measure things like voltage, current, resistance, continuity with different devices. And again, we're teaching them how to do that. We show them exactly how. So even if you as a teacher aren't feeling super confident, we've got you. Then we step it up again because some students are going to say, like, my car at home doesn't use a four-way harness. It has a different one. I have a really fancy trailer that we use to haul my UTVs, or I've got a cattle trailer, right? Or I've got a camper. What about those? And so that's when we step it up again. And in lesson 5, we figure out how to wire a 7-way, which from scratch, right? Just like you would buy from scratch a bare 7-way. I have this on my truck. We guide them through wiring up the harness and then how to wire the whole system, right? This is everything on a trailer, which is super cool. And then once they have it working, this I think is the most valuable part. All right. And this is where transference really gets like built. I had my students, they would build circuits, they would do it all, and then they come to me like, it doesn't work. And I would say, so what? What are you gonna do about that? And that was not the best answer for me. What I realized, and this is what we worked into this product, is students need to actually be taught the process of troubleshooting, right? Troubleshooting is like, if you look at different levels of learning and complexity, troubleshooting, right, is way up there in level of understanding. But to get there, we have to teach them a process to fall back onto. When I don't know what's happening, what's the mental model that I can rely on to guide me through figuring out what's wrong? And I worked with our SME to develop this. This is the process that he used as an electrician when something wasn't working. What's really cool is that the trailer simulator has 10 troubleshooting scenarios built into it. So on the top of that, the cab of the truck, there's a double-digit display and 2 buttons. And when it's set at 0, that's everything works. And if I push the 1, then it switches it to scenario number 1. And if I remember right, scenario one is like the rear right marker light doesn't work. So all of a sudden, the student's going to see this light that was working now isn't. And they have to figure out, right, through this process, where's the fault? Which, right, working through this, we guide them through it. We just don't throw them to the wolves. We guide them through it. We teach them and guide them through this 5-question sort of testing routine where they're using the multimeter and the auto test light. And again, you as a teacher don't have to be an expert. We provide all the keys and everything. And we guide them through reaching a conclusion and how to fix it, which is pretty awesome. So that student workbook guides them through those 10 scenarios. And this is super cool. I just love to mention this. One of the scenarios is a blown fuse, which is a really common, like real life fault when you're working with electrical systems, especially whether it's in a house and you got your circuit breaker, your fuse box, or an automotive system, right? Fuses matter or circuit breakers matter. We actually do have a working circuit breaker panel on the front. And if you take the multimeter and you actually test the 2 electrodes, it measures voltage or continuity, right? Just like a real working fuse would, which is so cool. Now, this is a kind of a cool hidden Easter egg. Once students have worked through all the troubleshooting, that means they've done lessons 1 through 7, right? They've developed some pretty amazing skills. They've put them, into practice with that troubleshooting. Is we built in an assessment mode. When you click both buttons, right, it puts the simulator into an assessment mode. And then part of lesson 8 is a troubleshooting test. They won't know what scenario you chose. They have to work through the test, right? Oh, shoot, what's missing? I'm missing a slide here. I apologize. And what I really love about this test, right? Again, thinking about transference, real world context matters. This test finishes with a sort of a scenario role play. They are now an employee at a local auto shop. Somebody has brought in a trailer, right? The trailer, it's not working. And so they have to actually like write out their customer response to their clients. What's wrong? How do they know it's wrong? What would be the fix? And actually role play that real world situation, which I think is always a great thing to work into these sorts of lessons. So just kind of summarizing, right? The trailer circuit STEM kit really is sort of a great introduction to practical electricity and how to use it in the context of an automotive trailer world. So this is just like a list of all, like really quick list of all the different things that we've worked into it. Here's that list continued, now in bold for some reason. And I put this continuum on the bottom because one of the things that I always pitch to my teachers is we want our students to be empowered, right? And that comes through being successful. And so one of the ways to think about what am I doing in my class and is it effective is, am I creating a learning experience that's moving students up on this continuum? I had students that, they would be over in the 0, 1, 2, like this is not who I am. And I'd be like, oh, all right, that's where you're starting. But my goal was always by the end that they somehow moved up and now they feel like, oh, I'm good at this. I can do all of this stuff. All right, this is for me. So this is just, this is the last slide with this one, a really cool product. I think it's a great way to sort of build in that electrical learning with a high rate of transference. Now, the other one I wanted to look at is our electrical wiring kit. The electrical wiring kit came from teachers saying, I need to teach students in a construction context how to wire, but I cannot create this in my classroom, right? Or some teachers do, they have a wall that they've built, but they've struggled with their custodial engineers or OSHA coming in saying, you can't do that. All right, so we created our electrical wiring kit, which is a really small tabletop system. And what I love about this is it is such a great example of setting the stage for effective forward transference. Meaning, if I can do it here, it's really easy for me to walk into let's say a house, right, that's been framed and it's ready to be wired. I can take what I did on this simulator and I can do it right there. So this is just some examples of students using it in the classroom, right? It's got a small scale, small structure. It's easy to have groups of students working on tabletops, right? And I think, let's see, what's the next slide here? What makes this thing really powerful is that you don't have to hook it up to live 120-volt power, right? So students can run their wires, from this little control center. If you can see my cursor right here, right? Run their standard 12, 14 gauge wire to the same types of electrical boxes that you would find. They install switches, light fixtures, three-way or single pole outlets, and then they can hook up really easily this battery powered tester, which if you look at that, if you've ever seen like the testing unit that an inspector uses, they'll plug into a unit. This shows the same codes that you see on those testers. And we've got a light socket tester and an outlet tester. And what that means is, right, a student can do the wiring. They've got the guides that we'll look at in a second. They hook up the tester and they get immediate feedback, knowing if they did it right, if they did it wrong, and then they can look at the codes right there on the unit and see how they did it wrong. Which means you as the teacher don't have to be the one telling them all this. They can work independently of you, and you can just keep moving around the room to problem solve and troubleshoot. The electrical wiring kit comes with, let's say, 12 different exercises, which if you kind of work through that, they go from simple to more and more complex. And again, you can pick and choose. And each one of those comes with a guide that helps direct students how to make those connections. And one of the things that I really like is, right, these are really standardized drawings. If you buy an outlet, let's say you go to Menards, you buy an outlet and you open up the little paper pamphlet, these are the same drawings you're going to see that showing those connections, which makes it, again, much easier for students to transfer that learning experience to the future. This is a pretty sweet product. If you're someone who's teaching construction, this totally makes sense. But I also think, like, as a science or engineering teacher, right, context matters. So is there a reason to teach electricity? Even if I'm a robotics teacher, to introduce or teach electricity from a construction perspective? Absolutely. So bigger picture now, let's talk about safe and effective implementation. This face is always the thing I'm trying to prevent as a teacher, right? Because electricity can be so scary, right? If our students are turned off, if they're disengaged, we've lost them. And so some things to think about when you are creating your electrical learning experience. These are 4 things that I really found helpful as a teacher to keep in mind as I try to create this balance. 1, that real world learning experience really does matter. If I'm just having students, play with coin cell batteries and some wire and an LED, that's not real world. Right? And they're not going to know how that transfers to the next thing. Making sure you're setting students up to have a positive and safe experience is so key. I remember so many times, right, that students, they blow up an LED and they're like, God, I suck at this. And they just put their head down, they shut down, right? So how do we make sure we're not setting them up for potential failure? I really loved using mixability teams with electricity because it took some of the pressure off the students who are more nervous about it, or maybe just didn't have as many, prior skills from other learning experiences. And that also sets the stage for when students are working in teams, is to give them actual defined roles. And this setup I used quite often. And I think would fit perfect with both trailer circuits and the electrical wall panel, right, is actually defining roles and then switching students through them. So having that student who is identifying themselves as not as confident, let them be the apprentice, right? And this sort of reinforces that future career path. Like when you decide if you want to be an electrician, right, you usually start out as an apprentice. They don't expect you to be an expert. And then having that student who's like, there's always that one kid who's like, no, I want to do it. I know how to do this. I know how to use the tools. I've done this before. Let them be the electrician, right? But one of the important things is you can't let them do everything, right? So like they're there to guide the apprentice, but because they have more experience, they get to do more of the connections and such. And then the engineer is sort of like that big picture view. And that's where having that student workbook, right? The engineer is the one who's managing the slideshow, that's directing students, but also keeping track of that student notebook and making sure everybody's staying on task with getting that individual work done. Because accountability is a huge piece for me, right? I don't want the apprentice just sitting there doing nothing because they think the engineer is taking care of everything. Every student is going to have to turn in that student workbook, all of them as individuals. Some resources that I wanted to show you guys. One of my favorite things in creating electrical learning experiences that were really successful was using Tinkercad. Right. Now, most people think of Tinkercad, if you go to that website, tinkercad.com, as a place for 3D design and 3D printing. But also built in there is this really fantastic circuit designer and simulator. Right. And so what I would do is, I would do my electrical learning experience, right? And then we would launch into our challenge. And part of our challenge, maybe it was that LEDify, right? Taking the stuffed animal, gutting it, let's build a circuit, put it into the stuffed animal, make that sucker glow. Part of that challenge was using Tinkercad because I found that it really helped with transference of taking that hands-on learning experience and putting it into this new context. And so what I would do is, as part of this challenge, is these 5 steps, right? We would think about, all right, I'll use the example of the LEDify, the stuffed animal thing. You got this stuffed animal. Let's brainstorm and let's sketch out on paper what you want this stuffed animal to look like. So we'd sketch it out. And a lot of them, they love making like creepy glowing eyes, right? So, all right, you're going to have 2 LEDs, okay? Where's your battery pack going to be? Are you going to need some resistors? Let's plan this out. But then instead of having them go and build it, right, is we would go into Tinkercad and we would actually build it in Tinkercad, right? Because this is, right, you can't fail. If you mess up, you can just play around. And then what's really cool, I don't know if that's blocking there, right, is they've got a simulation mode. So I build the circuit and then I click the start simulation and it in effect turns on the battery and lets current start flowing. And I could flip the switch and I would see, did I build a circuit that actually works? And if it doesn't, right, it's way easier for me to troubleshoot and problem solve why it doesn't work here than on the table. For example, this circuit, I've built in a short circuit. This wire should not exist right here, right? So if I did run a simulation, I would see that this circuit does not work. Once they get it working in Tinkercad, then they're up for step 4. They build it in real life. Step 5, they can compare it. What did I build on the table to what did I build in Tinkercad? And if it's not working on my table, it's really easy for me to look at what I did in Tinkercad and try to figure out what's going on. I had a huge success with this process, especially with thinking about how to make that learning transfer. The other resource I want to point out to you is our website and this resources tab on the very top. I don't think a lot of our customers, our teachers know how much stuff is hiding on this website. And so I just wanted to point it out to you guys. If you go to realityworks.com, you click on resources, there are so many things here that as a teacher, I wish I had known about because Sometimes I just need help coming up with ideas. And man, do I love it when other people have done the work for me. So if you have a chance, check this out. Also on our website, we just looked today at the electrical wiring kit and the trailer circuit stem kit. But as a teacher, there's a ton of other things out there that are super helpful. They don't necessarily do with electricity, but just phenomenal products that really are designed to help teachers be successful and create really engaging learning experiences. And with that, I'm going to turn it over to Kelsey to wrap it up.
Perfect. Thank you, Todd. Yeah, so now what? We gave you a ton of information. So just kind of reiterating some stuff that Todd said. If you are interested in a consultation to speak with one of our account reps about, the products we talked about today or a different product, you can click on this form, which we will send out. And I'll also put that link in the chat. And then there'll be a QR code that you can scan as well, if that's something you're interested in. We have a lot of awesome implementation resources that we've linked. We do have our welding month giveaway going on right now. So be sure to enter that. That goes till the end of the month. And then we also have awesome blog posts. The one I linked is about electricity. So be sure to check that out and contact us with any questions you guys might have. Once again, there's that QR code. If you are interested, you can scan that, and I put the link in the chat as well. And now we will jump into some questions here for you, Todd.
Awesome.
So first question, are these two products that you spoke about, are they suitable for middle schoolers?
Absolutely. One of the best things about, right, middle schoolers are fantastic. They've got so much energy, and they love to just be hands-on and work together. And both of these products are great for small teams of 2 to 4 students working together, which is a recipe for either success or or failure, with electricity at the middle school level. But that's the great thing about both of these is you can teach electricity and not worry about them blowing stuff up, sparking things, getting shocked, or just like destroying your really valuable components. So absolutely, these are great for middle school.
Perfect. And then another question here, kind of tying into the middle schoolers, but maybe a little bit different way of looking at it. Are these kits suitable for beginners who have never really dealt with any electrical work before?
For sure. If I was gonna rank the two, I would say the trailer circuit stem kit is looking at the curricular materials is a little bit better suited for developing that beginner understanding because it does dive into the foundational concepts of what is voltage, what is current, what is resistance, what is Ohm's law. It even does a little of the math with that, and then it slowly eases them into how to build circuits and how to use the tools. The electrical wall trainer, the panel, is a kind of assumes that you already have a little bit of that knowledge. And so it doesn't give as much of that beginner guidance. But also really easy to figure that out for sure.
Perfect. Well, that is all the questions I'm seeing at this time then.
Awesome. Thank you so much for joining us today. I really appreciate your time, and please let us know if you guys have any questions. Have a wonderful rest of your day.